Hi, this instructional video is about graphing and classifying conic sections. Translated, that is. In order to graph something like this, we have to first understand the standard form of the conic section so that we can classify it. They are given as ax squared plus bxy plus cy squared plus dx plus ey plus a constant f is equal to 0. Now, out of this standard form, we have to identify the a, b, and c. Here, the coefficient for the x squared is the a, so that's 1. b, the coefficient for the x and y term, well, it's not here, so it's a 0. And the c, the leading coefficient for the y square, is identified as 1. So c is 1. And what we're going to do is use a discriminant that we learned back in Algebra 1. In this case with an uppercase to signify all the different coefficients. So b squared minus 4ac. In this case, the b squared minus 4ac. When we substitute all the coefficients, we get 0 squared minus 4 times a, which is 1, times a c, which is 1 as well. What we end up with is negative 4 times 1, which is negative 4. What turns out our discriminant is less than a 0. It's a negative. And there's a rule about that. If the discriminant is less than a 0, then the conic section, later on when we graph it, it can either be a circle or it could be an ellipse. Well, how do you know whether it's going to be a circle or an ellipse? To be a circle, it has to meet two conditions. The b, you have to ask yourself, is it 0? Yes. And another condition is, and it must meet both conditions. Does a and the c coefficients, do they equal? Yes. Then it's a circle. Otherwise, if the b did not equal to 0, or, now this one's either or, a does not equal to c, then it's an ellipse. But in this case, it meets both conditions of a circle, equals to 0, and the a and the c equal each other. And the standard form of a circle, when it's translated, is given as x minus h squared plus y minus the k squared equals the radius squared. So we're going to try to make this standard form into the form of a circle. So let's take that standard form, x squared plus y squared plus 14x minus the 2y plus 49 is equal to 0. And we're going to make it into the standard form of a circle. First, let's regroup, put all the x's together. So we have x squared plus 14x. Now let's take the y's and group them together. Y squared minus 2y. And the constant 49, let's move it over to the right side of the equation. And why is that? Because we're going to use the complete the square method. Complete the square. And we're going to take two different polynomials and make into a perfect square trinomial. So x squared plus the 14x. And the rule was in the past, to complete the square, you take half the b in this 14, and half of 14 is 7. And 7 squared is 49. And since I am adding 49 to the left side of the equation, later on I'm going to have to add 49 to the right side as well. But before that, let's also complete the square of the polynomial with the y terms. So plus y squared minus a 2y. Now what's half of a 2 is 1. And 1 squared is still 1. So since I'm adding this one, I'm going to add that to the one on the right side as well. So the constant 49 was already there, plus the 49, plus the 1. Let's simplify the trinomials on the left side of the equation. So when we factor this, it's a special product property. So we get x plus 7, another x plus 7. So we're going to write it as a square. And the y trinomial, y minus 1 times y minus 1 will give you the square of a binomial. And on the right side of the equation now, negative 49 and positive 49, they're additive inverse. So they truly cancel out, leaving you with a 1. And look, it looks just like our standard form of a circle now. Except the 1, well, if you square it, it's still 1, so that's a good thing. So that's our standard form. From there, we could identify the new center. The new center of this circle that's translated from the origin. The h and the k, which signifies the new center, is given as the, look at that, see? It's a minus h and minus k. So we're looking for the inverse of the h and k. So in this case, h is going to be not 7, but negative 7. And not negative 1, but positive 1. That's the new center. And what's the radius? It's the square root of 1. So we can graph now. So we have on the x 1, 2, 3, 4, 5, 6, 7, negative. And y is 1. Boom. And from there, the radius is 1 in all directions to each of the point on the circumference. So 1 here. And I guess the coordinate for that will be negative 6 and 1. 1 here, which will be negative 7 and 0. 1 here, which will be negative 8 and 1. And 1 up here, which will be negative 7 and 3. Oh no, 1, 2. There it is. So we could sketch our circle now. And there it is. And the radius is 1. There it is. Okay, so now that you see the example of how to classify and graph a circle, let's have you try one on your own, given this standard form to classify the conic section. Try it. Okay. So, in order to start classifying, we have to identify the A, B, C. So A is going to be 1. The B, well, there is no B. It's the one with the x and y term. In fact, let me write that over here. ax squared plus bxy plus cy squared plus dx plus ey plus the constant f equals a 0. That's a standard form to classify the conic section. So once again, there is no xy term here, so it's a 0. And the c is the 1. So now we're going to use the discriminant. B squared minus 4ac. That's going to be 0 squared minus 4 times 1 times 1. This looks so very familiar, just like last time. So that's going to give you negative 4. And since negative 4 is less than a 0, we have a possibility of this being a circle or an ellipse. And once again, remember the circle is classified by the fact that the b has to equal 0, yes, and the a and the c equals, yes, they do equal each other. So it's a circle. And we are looking for a standard form that goes x minus h squared plus y minus the k squared equals the r squared. So we'll take that standard form, x squared plus y squared minus 4x plus 6y plus the 4 equals to 0, and start making it into this thing. But first, let's regroup this thing. So we got x squared minus 4x. And what's half of the b? The 4 is 2. 2 squared is 4. Now the y terms, plus the y squared plus a 6y. What's half of the 6? It's 3. And 3 squared is 9. And at the same time, let's move that 4 over to the other side so we could complete the square. So negative 4. Now, since we gave the 4 and the 9 to the left side of the equation, we have to do the same thing to the right side. So we go plus 4 plus 9. And let's simplify it by factoring. So x minus 2 squared plus y plus 3 squared is equal to negative 4 and 4 cancels out. So we have 9. 9 is a perfect square. Good for us, because now we can identify the new center of this circle and the radius as square 3. So there's my standard form. What's my new center, h and k? It's the inverse of the given h and k. So in this case, negative 2, so it's going to be positive 2. Instead of a 3, it's going to be negative 3. And what's the radius from that new center? It's going to be 3 units all the way around. So we could graph now. So we got 1, 2, 1, 2, 3. There's our new center. And from there, what's the radius? It's 3 in all directions. So 1, 2, 3. So it's going to be 2 and 0. 1, 2, 3. This away. So that's going to be negative 3 and what is that? 5. And it's going to be 1, 2, 3. So it's going to be 2 and negative 6. And 1, 2, 3 this away. Ouch. And so there's going to be, what is that? Negative 1 and negative 3. And so if we sketch our circle, it should look like this. You got the idea. And of course, you should do the courtesy of indicating the radius. The radius doesn't look so accurate this way, so let's make it this way and say the radius is equal to 3 units from the new center, which is the coordinate 2 and negative 3. There we go.